So fine. So last class we have saw like working with multi-threading, right? We have saw multi-threading, and what did I say? You right? Threading will improvise the performance, but in threading also we have a problem. What is the problem? When you are working with threading, the problem what we have with threading is not like any error or issues. Even though we have multiple cores under a processor, threading doesn't use all the cores. Threading uses only one core. Threading uses only one core of the processor. That's what I said here. Even the multiple threads are created by a program, all this will be created under the same core. So if at all you just wanted to improvise this performance, if you want to improvise the performance, what you guys can use is you can just use the concept of TPL, task parallel library. In TPL, threads are replaced with task. So in case of the thread, now you are going to create a task class instance. And when you create a task class instance, task will create a thread. Are you clear? So let us rewrite this code now with tasks. Let us rewrite this code now with tasks. Okay, we'll rewrite all this code with the help of the tasks now. Let me add a new class. I'm copying these three methods as it is here. As it is, all the three methods, what I shown you. This is the third time we are using this method. First, I shown you without multi-threading. Second, I shown you with multi-threading. Third, I'm showing you with the tasks. Okay. And guys, to work with the threads, you require to import system.threading namespace, right? Yes or not? And already we discussed like thread system.threading is a default already imported. Already imported. To work with the task here, to work with the task, you require to import system.threading.tasks namespace. The namespace is different. System.threading.task. And this is also a global import. Did you understand me or not? This is also a global import. What? System.threading.task is also a global import actually. So I don't require to import anything now. Okay. Well, just like you created a thread class instance, now create a task class instance and pass the method as a parameter. Is the same thing you've done with thread also in the last class. Are you clear? There's the same thing you are done with a thread also in the previous example. You've done the same only with the threads also. What you done? You created louder thread class instance and pass the method. Here we are creating task class instance and passing the method. Both are same. And what we do? We call start dot start. Now also the same T2 dot start. T3 dot start. And here also done the same thing only. Start. And third one is you record to call the join. Remember? What is the join? If I don't call join, main will exit the program first. If I want the main to wait until the end of the program's execution, we just require to call thread.join. You see the difference? Console.writeLine, main thread is exiting. I am writing a statement. Console.writeLine, main thread is exiting. Who is executing this method? Main method. Sorry, this is the main method. Executed by main thread. So once the method execution is completed, automatically what will happen? Main thread will exit. Okay, I commented join, guys. I commented join. Run this. Just a minute. We put a sleep of 30 seconds. Yeah. Let me make it as 5 seconds. See, may the thread went to sleep for 5 seconds, wakes up, completed the work. But in the last, you written a statement, main thread is exiting now. Where is that output? Let us see. Once all the three threads started, one started, two started, three started, all the three threads started, the job of main is completed, main is exiting the code now. Understood or not? What is the main thread doing? Creating a thread, starting it. Second thread, starting it. Third thread, starting it. Main job is completed. So main will immediately exit the code. Main will immediately exit the code. So that's the printing on the top only, see? But this should never happen here. Main is the controller. The complete control will be hands of the main. So main cannot exit the code like this. Main has to wait until all the threads are exiting from the code. Main has to wait until all the threads are exiting from the code. If that is the case, I explained in the videos to you. What is that? You're required to call this. What is that? Join. So when you call join, what happens? Main is going to wait until all the threads are exiting from the code. Main is going to wait until all the threads are exiting from the program. It is going to wait until all the threads are going to exit from the appropriate program. That's what exactly the main does. Are you getting me or not? So that's why you require to call the join. See the difference? You're waiting for 5 seconds. Even that 5 seconds, the main is also waiting now. Are you getting me? There is a store manager, a retail store manager. You open the doors now and customers coming and purchasing something. 9 o'clock stores has to be closed, but still customers are present. When customers are present, let them do what they want, and the store manager will leave the store now. No, you cannot leave. What is your job? Wait until all the customers leave. Don't allow new customers inside now, but all the existing customers leaving the store and then close the doors. So once my time is over, I cannot leave the store and get away from the store now. So same way, main thread also cannot exit from the code like this. Main thread has to wait until all threads are completing their work. Is it clear or not? What is it? Main thread has to wait until all the threads are completing their work. Until all the threads are complete, once every thread is completing the work, then only main has to exit from the code. Until then, main has to wait there. And to do that, what do you record call? Join. And coming back here, what we done today in the place of thread, we created task. And here, start. And then we don't have join, guys. In place of join, we have wait now. The name of the method got changed now. What is the name? Wait. Or okay, just a minute. Wait. You won't find any difference basically. Now also threads are going to will be available. But which class instance you created? Task will create the thread instance for you. What will it do? Task will create the thread instance. See now also? Main is exiting last. And if you want the main to exit last, what do you require to call? Wait. If I don't call wait, what will happen? Main can exit in the middle when the execution is come, when its job is over. Main can exit in the middle when its job is over. But when I write this, when I just write wait, it is same like our join. It is same like our join. Did you notice it here? I did not call wait. Main immediately skipped out of the program now. It's not waiting for anything. No output came. Are you clear? That is why we should not allow the main to get out of the program until all are done. So for that, just like join, here we should call wait. See, what is the first step to work with the thread? You have to create a thread class instance and pass the method. Now replace it with second step. You need to call start on all the threads. Now call start on all the tasks. Third step, call join on all the threads. Call wait on all the threads. That's it. Everything is same only. Just execute and run the code. Now also threads are created. See, IDs are printed, see? And all are given equal priority to run the code. And suppose if any thread is taking more than the expected time, come here. Let's add the condition. If is equals to 20, thread dot sleep. Thread dot sleep. Oh, I is equals to 50. thread dot sleep. I'm giving some time. See, now also you can see 1 and 3 are done. After 20 seconds, it will wake up and complete its job. We put a long time, 20 seconds. But after 20 seconds, 2 will wake up and complete its job. See that. From 51, no other thread is there. Why? All are completed their work. Finally, there are 3 customers here doing some shopping. First customer left, second customer left. Third customer is still doing some shopping. You're waiting for him now. When he too gets out, then only the store is closed. Exactly. Understood? Okay. So the behavior will be same. Actually, for a task here, we can call sleep here, or otherwise you can call task dot delay. Task dot delay dot wait, I think. Yes. For tasks, what we use is so 3 and 1 completed there, see? Waiting for 1. After 10, waiting for 2. After 10 seconds, 2 will do its job. No. Task dot delay dot. Oh, no condition here. If I is equals to 50, condition is missing. 3 completed, 1 also completed. Yeah. So in the place of thread dot sleep, what we use? Task dot delay dot wait. Thread dot sleep also works here. Both will work, man. Thread dot sleep also will work, as well as task dot delay dot wait also will work. But thread dot sleep is much simple and easier. We can try that also. Okay, guys, are clear? Yes or not? So this is about how you write using tasks. What is the advantage? I have 4 threads in my code. Main, thread 1, thread 2, thread 3. Now these 4 are created on 4 separate cores. But in the previous program, all 4 are created on the same core, but now they are created on separate cores. So on one core, 1 thread is created. Mine is a dual core, quad core processor. It is using all the cores now and utilizing. Tomorrow, if we have more than 4, then what happens? Distributes, man. There's 6 now. Or in 1 there will be 2, and another 1 there will be 2, 1 will have 1 only now. 8. Distribution like 1, 2, 3, 4. Next again 1, 2, 3, 4. Like this, will keep on filling up the cores to you. It uses all the cores of your processor. That is the advantage of task over threads. So you can create a thread class instance or either a task class. Thread is old model, task is new. From now, in the latest applications, we don't use threads anywhere. In the place of thread, we are replacing it with task now. Are you getting me or not? We are replacing thread with task. Threads are now replaced with tasks, guys. Yeah, join. No, delay dot wait, not wait. Join and wait are same. Join here and wait here are same. Just a minute. In threading, thread task. Here we have join and here we have wait. Here we have sleep.
Recording in progress.
And here we have delay dot wait. Sleep will take milliseconds. delay also will take the milliseconds. Dot wait. This is how you should call. Are you clear? But don't forget, sleep also will work in task. Okay now? Okay, one more thing I'll show you. Just watch. Observe these two. What are you doing? You're getting a thread task first and afterwards starting the task. Are you clear? What are you doing in the first line? Creating the task. Second step, starting it. We can write these two in one line only. We can do both these two actions in one line only. In tasks, both these two things can be done in one line. See, I'm commenting this code all of you. And I'm writing this in another style. Task T1 is equals to task dot factory dot start new. You can write like this here. I don't see any expression on the faces here. Understood or not? There's no need of calling start again separately now. That will do both the two activities to you. What is that? Creates, starts. You don't require to call start again separately. Okay, again. Task data is equals to task dot factory dot start new print 2. Next. Task T3 is equals to dot start new print 3. Okay, now I need to call wait now. I don't require to call start any wait. You can call wait like this also. One way of calling wait is T1 dot wait, T2 dot wait. Suppose 10 tasks are there, I need to call T1 dot wait, T2 dot wait, T3, T4, T5, I need to call. Without that, you have another option. Task dot wait all. There's a method called as wait all. And this wait all takes a parameter. What it takes, see? Task array. Remember when we use params there, array values can be directly passed. So now can I directly say T1, T2, T3? Is another style of writing. Without calling wait on each, you can call wait all and you can pass all this in. This is one style of coding. This is another style of coding. Are you clear? Watch it. You should get the same result now also. Is it clear? Okay, fine. So finally, what is your conclusion? No more threads. Replace with task. Everything is same, but means everything is same in the sense behavior is same. Now you will create task. The task will create thread. The behavior is same. I'm not explaining about the behavior. The behavior is what you learned in the video. That only. But now you have more better performance because it's trying to use multiple cores of the processor. And also, they made the things a little bit simple. They made the things a little bit simple with the task compared with threads. What is that? This is how you write code in threading, right? And the same mechanism is available for you in task also. Next. This is a simplified version. This is a simplified version. You can write the code like this. Okay, next. I asked you to do this in the last class. Have you checked out if at all your method is parameterized? If at all your method is parameterized, we cannot call a parameterized method directly by using thread. What you're required to do? You're required to take the help of a delegate. What is that? Thread start delegate. What is that? Thread start delegate. You're required to create the instance of a thread start delegate and use it. But when you come to task parallel library, you don't need all these things. The things are very, very simplified. Let me show you now how to call a. First, we'll start with value returning methods. I'll show both. First, let me start with value returning methods. Afterwards, I'll show you parameterized methods. First, we'll start with value returning methods. If a method is value returning, how do I call by using thread? In this class, let me write a value returning method. Okay, we'll do it. All of you can observe. There's a small method I have in the code. Can you tell me the logic of this? Can you describe the logic? What did I do? What did I do? Louder, don't whisper. What is the logic of the program? I don't hear anything what you are speaking. We are length of the stinger. Oh, directly length of the stinger. What is all this nonsense? All this is nonsense. I asked you describe the logic with length of the string. I don't know str dot length of the string. What is your answer? Foolish answer. Tell me the whole logic. What is happening? What is given? No. What is this for loop doing then? For loop is sleeping there. What is it doing? We are brainless fellows. Plus equals to this concatenation. First tell that first. What is happening? You're concatenating the values now from where to where? 1 to 1 lakh. No head and nothing. Directly end of the thing. That's all. Length of the strings are what length? Your length. Asking you what if there are 5 lines of code and you're not able to explain it. Yesterday I saw you, your talent in the lab yesterday. Your teacher asked you, what are the classes in the system dot data? He's teaching you and no one is answering. You completed video.net. I saw in the yesterday, 11 o'clock, I was in the lab. And someone is teaching you the classes, right? Yeah, some batch is present. I saw the students also. Someone is present in the lab. And the teacher is asking you what are the classes in system.data. I explained you everything in detail. What classes are there in system.data, system.data.sql client. Everything I said to you, and you're not able to answer. And you will be telling me again, hey, what are you studying here? Like this only you'll get off jobs. Simple 5 lines of code, you're not able to describe it. Tomorrow you go and answer like this, you get out from here, you say. What is happening? You should tell line by line now. What happened in the first line? Empty string is declared. Next, a for loop is running for 1 lakh iterations. Next, concatenate all these values now. Concatenating all the values. So what happens? 1, 2, not adding, concatenating. It's concatenating from 1 to 1 lakh and finally telling you what is the length of that string now. It is telling you what is the length of that particular string. The string length is what it is going to give you. It is a method I'm writing. It's a value returning method. Same way, let me write you another method here. This is simple. What is this doing? See, it is converting hello world into uppercase and returning the string. So I have 2 methods. Don't bother about the logic what is present. But see now you have 2 methods. One method returns a integer. One method returns a string. So now I want to call these methods by using a task now. I want to call these methods by using task now. How to call it? See, listen. Now, actually, in the previous example, we created a task class instance. We created a task class instance. Task T1 is equals to task T2. Now also same. But there are 2 task class available. One, normal. Second one, generic. Generic. Remember generic? Say, task of 2 tasks are there, see? Angular braces indicates what? Generic. It is generic. See now, task of int. Listen guys, task of int. T1 is equals to new task of int and pass the method name there. What is the method name? Get length. Come on, you tell me the second one now. task of string T2 is equals to are you clear? Next, T1 dot start, T2 dot start, T1 dot start, T2 dot start. Now, when you call start, both will execute. Now, the result will come back. You need to capture the results now. Yes or not? Okay. Int result 1 is equals to T1 dot result and string result 2 is equals to T2 dot result. Do you remember this one? What? Suppose you create a stack instance. If you create a stack class instance by passing int as a parameter, remember every member inside of the class will change up to int type now. Push will take int, pop will return int, pick will return int, all will change up. Suppose you create a string, now all the methods will change up to string type now. Here also, T1 is taking, so result is going to be integer type now. Integer type what? Task of int. Same way here, see? Is a task of string. Now it is string type. You got your results now. Console dot write line. Result 1. Console dot write line. Result 2. Okay? Well, now I did not call join, wait there, right? Or I did not call wait there. When you're calling result, if you don't call wait, also no problem. When you're calling result, even if you don't call result also, wait also, no problem, because the result will come after execution only. Are you getting me or not? Result will come after execution only. So that's why result will internally wait the program. You don't require to call a wait again here. See, now also it runs to you. So no output coming. Yeah, you're concatenating between 1 to 1 lakh. It takes a lot of time to do it. See the size of the string now. It's 4,88,895 is the string length now. Is that clear? Because the concatenation is happening between 1 to 1 lakh. So it is 4,88,895 is the length of the string. It takes time. And now see, even though I did not call wait hour, it waited for these 2 lines of code. But earlier, if I don't call wait, directly last time will print of now. But now it did not print. Why? Result is called. Result will make to wait. Did you understand how to call a value returning method? Tell me. It is a value returning method. So we are calling a value returning method. Now, sir, how to call parameterized method, sir? Could combine. What is that? Parameterized value returning. Understood? What will do? Parameterized value returning. Both I want now. I want parameters also. I want value returning also. Okay, just a minute. Guys, you can write this code like this also. Task of int T1 is equals to task dot factory dot start new get int. Task of string T2 is equals to task dot factory dot start new to upper. Okay now? So that is also same only. First way, second way. But in both the 2 cases, notice it, I did not call wait. I did not call wait or did not call wait all. Nothing I called here. Okay. Now my next example I'm showing you is how to call parameterized value returning methods. These are non-parameterized, right? How to call parameterized value returning methods. Okay. Observe. Nothing here. I'll copy the same 2 methods here. I'll copy the same 2 methods. Now see, these 2 methods are static now. I'm not talking about this one here. Static in behavior. Always they will calculate 1 to 1 lakh only. This one always to upper into uppercase only. But I want to get the length of the, I want to tell this value dynamically now. I want to tell this length dynamically now. So what should I do? Now see, when you're calling this method, you're required to tell, you want to find out the length of 1 to which one now? 1 lakh, 2 lakh, 3 lakh, you can tell on your choice now. Are you clear? And again, here also. What should I do? String, yes, here. The same only, now I made it dynamic now. I can pass my own number here. I can pass my own string here. And now also these are value returning only. Okay? How to call? Static void main. Come on, how to call parameter value returning? Task of int T1 is equals to task new task. And here we pass the method name. What is that? Get length. Correct now? We pass the method name. What is the method name? Get length. But now we need to pass the value also for it now. We need to pass the value also for it. I'm passing the same 1 lakh only. We can change it. Okay? But just a small thing. And this is the same thing what I explained you earlier. But here we have a small difference. How to write this is, if it is parameterized, you require to open the braces, use a lambda, and then write the code. That is the difference. Understood or not? If it is a normal non-parameterized method, what do you write? Get length over. But this is parameterized. It requires input now. Okay, how do you write? That's how you should write. But one more thing. Before that, we require to use a lambda. This is what. Come on, you tell me the second one now. Task of string P2 is equals to new task of string lambda to upper something. Next, T1 dot start, T2 dot start. Rest of the code is same. Again, the same thing. It is going to concatenate between 1 to 1 lakh. I did not set it up. Okay. Oh, sorry. Then also you should get the same result only, no? But now it is hello Hindi, I think, not hello world. But that 4888895 should be same now also. You can pass your own value. I want to just find out until 50,000 only. Only until 50,000. Is that clear? Yes or not? Sir, how do I call parameterized non-value returning methods? We'll use normal task without using a generic. Parameterized non-value returning. Parameterized non-value returning is what we should use. Normal task, not generic task. You put your cases like that, yeah. Already you saw non-value returning. What should I use? Normal task, not a generic task. Try it. You try it on your own. Go for writing a non-value returning method parameterized. Process same, but you should use Normal task, not a generic task. You cannot use a generic task there. Okay. Yeah. Come on, guys. Can you write this in a single line? Task of int T1 is equals to task dot factory dot start new. Get length. Next. Task dot factory dot start new. Sorry. Two. There's other way to write. Is that clear? Okay. So you try parameterized. There are 4 types of methods. Shown you 3. Non-parameterized, non-value returning. First one. Second one, non-parameterized value returning. Third one, parameterized value returning. Fourth one, parameterized non-value returning. You try. Okay. Same code. What is it? You're required to use a normal task, not a generic task. You should go for using a normal task, not a generic task. See, first calling value returning methods. Next, with parameters. With parameters. Next, thread synchronization. Remember this concept I find in the video. Thread synchronization. What is it? Actually, when you use multi-threading, we call our applications as asynchronous. What is that? Same thing I explained you with the JavaScript, Ajax. Asynchronous JavaScript in XML, foreground and background activities. Now also asynchronous programming. What is that asynchronous? One activity is going to be done in one side, one activity other side. See, 3 methods running parallelly now. That's what we call as asynchronous. Sometimes asynchronous programming can cause us problems. Sometimes asynchronous programming can cause you problems. Like what? There is a bank. For this bank, we are building an ATM application. There's a bank here. For this bank, you are building a ATM application. Imagine this is the database containing the customer ID, name and balance. $101. Some name, balance. Is that clear? I have a table. I have some set of records now. And now I'm building an ATM application. Now what happens when you're building an ATM application? What did I say? All servers are multi-threaded. Now, the first customer visits the application server. Application server will create a thread now. Application server will create a thread. And that is associated with the customer. Associated customer. Imagine like the first thread that is created here is linked with the account 101. Another customer came now. Another customer came on another machine. And this particular customer is associated with 102. One more thread is created now. One more thread is created. T2. Are you clear? So one customer, thread 1 associate 101, and the customer T2 associated with, no problem here. T1 is associate 101, T2 is also 102, executing fine now. But this is a joint account owned by two people. Unfortunately, what happened, not done intentionally. It's a mistake. Because a joint account, both customers visited two different ATMs at the same time unknowingly. Can happen. Chances are there, na. What happened? One customer visited machine 1, when the customer visited machine 2. Both are connecting to same server only, na. So what the server do? Server created one thread now for customer 1 and linked it to 103. Unknowingly, another customer visited joint account. Okay. Another customer visited another ATM now in another part of the country. So what happens? One more thread is created now. See the problem now. Two threads are connected to the same record. First one, not a problem. T1 connected to 101 and T2 connected to, not an issue. But the problem is with the third record. T3, T4, both are connected to the same record. Are you guys clear? When both are connected to the same record, there is a chance of having a problem. There is a chance of giving a problem here. What is the problem? The problem is like, basically this works on time sharing now. Threads are working on time sharing now. Operating system gives priority for everyone and tells every one of you to run. Okay? When I'm working on time sharing, already we saw that in the videos also explained here. When will the control transfer from one thread to another thread is not in my control, that is controlled by operating system. That is controlled by operating system. So what happened here, in this case, first customer was trying to check the balance. How much is the balance? 25,000. Same time, the second customer is also trying to check the balance now. How much? 25,000. Okay. Now, after checking the balance, the first customer is trying to withdraw some money now. Withdraw some money. Is trying to withdraw some 5,000 rupees. Okay. Now, the control is present here. And 5,000 is deducted. Remember, I explained the process. First, this change will be done in the application server. Afterwards, it will go to database server. Okay, now, what is the leftover? 20,000. And this should be updated to database. This should be updated to database. Are you clear? But meanwhile, context, the thread switching will happen. Operating system will transfer the control from one to the other now. So in this process, before this data is updated to database, how much should be updated? 20,000 should be updated to the database. What happened, Operating system transferred the control to the second one now. So this is pending now. Where you stopped? Deduction is done. Update is not completed. Stopped. Now the control went to where? The other one. And this person thought like, okay, 25,000 is there. And he thought of withdrawing 20,000 rupees now. Array 20,000. So if you withdraw 20,000 now, what is the balance? 5,000. But what happened here, in the given time, say, did you notice it? Thread 1 printing 1 to 3. Thread 2 also doesn't print 1 to 3 only. It can print you only 1 or 1 to 5. You noticed it or not? In the given time, what happened, here, modifying and updating also completed. Are you getting me? Modified. Now, it went to database and updated also. That work is also completed. What is the balance? 5,000. So, your transaction is completed now. Whose transaction? Now, OS stands for the control to. Now, you're pending in the middle. Now, we'll update this 20,000 to database. Do you know what happened now? How much is your balance here? How much is withdrawn in both the two machines? 25,000 withdrawn. What is the balance? 0. How much it is showing you? See now, if you develop applications like this, within no time, the bank will close the doors now. Yes or not? Ray, wrong. See, that's what I'm telling you. Asynchronous programming is good when each one is dealing with separately. But asynchronous programming is dangerous. See, the same problem I explained you with your applications also. Application also say multi-user global data. When multiple users are trying to interact with the application at the same time, wrong results will come now. And to overcome this problem, what did I say? We need to use locking. We need to use locking. Here also, basically, here we are using asynchronous programming. Here we are using asynchronous programming. But be careful. When each thread is working with a different record, not a problem. But we should never allow multiple threads to work on the same record at the same time. Multiple threads to work on the same record at the same time. So in this type of scenario, we're required to bring back to the traditional model. What is it? Synchronous programming. What is it? Synchronous. Right now, what is working? Asynchronous, which will be brought back to synchronous. And that's what we call as thread synchronization. What is that? And if you want to get thread synchronization, you are required to use the same technique what I taught you with the applications. That is lock and unlock. Locking. What we should use? Locking. The same, there is a present in threading videos also. We had the same in threading videos also. They also explained you these things. Are you clearer or not? See the impact of asynchronous programming first. See the impact of asynchronous programming. Let me write a simple method here. Static void display. Okay, I'm writing console.write C sharp is. And the next line I'm writing right line object oriented. So actually, these two are two statements now. First, print method will execute. Next, print line method will execute. Understand here? Now one thread is calling two methods now. One first method, right. The second method, right line. Are you getting me? Right. What it means to C sharp is, but the right method will not transfer the control to the next line. So cursor will be on the same line. Now, the second method will print out object oriented and comes to the next. Let me say to print you C sharp is object oriented in one line. Correct or not? Now, I want to call this method for multiple times. Which method? Display method for 3 times. No multi-threading, man. No multi-threading. I'm calling the display method for 3 times. Okay. And observe it. You will get the correct output now. Perfect output. No problem at all. Why? This is single threaded model. This is first method executed, second method executed, third method executed. But bring threading now and introduce asynchronous programming now. Now come on, let's try. What should I use? Directly I will say directly I'm using out the second option, display. See, man, earlier each thread is calling a different method, but now All threads are calling the same method. Okay, the same example what I said here. Multiple threads are accessing the same record. Same way, multiple threads are calling the same method. I'll tell you one thing. Now let me run the code. If you are lucky, you will get the correct output. You did not get the correct output, see now? I said you one point, if you're lucky, you'll get the correct output. When you will get, I don't know. Yeah, got it. Why, sir? In the given time, if it is able to complete the work now, fine. You are not able to complete the work. Second thread will interrupt it. That only I said you. Here I explained you that only. In the given time, this was only able to update but not save the database. But in the second one, able to update and also save. But if this only updated and saved, the problem would not come here now. Yes or not? But problem is, in a given time, all cannot run in the same speed here. Are you getting my point here or not? Okay, I will write a program. You cannot match my speed because I have that much of experience in that. I have that much of experience. Okay, so where I should use an uppercase, where I should use a lowercase, how to use IntelliSense, all the mere fingertips. Since 15 years, I'm doing it. You cannot match my speed now. Yes or not? So that's what you cannot expect everything should happen in the same way now. All cannot do in the work in the same speed. Are you clearer or not? Understood my point here? So that is the important point. So that's why I said, if you're lucky, you'll see the correct result. See now, again, what happened? That one started. Before it completed the work, control transferred up to thread 2 now, thread 2 started. But see, thread 2 was able to do its work on the time now. Are you clear? Again, control went to thread 1 and afterwards thread 3. You won't get the same result, see now, you got a different result. Okay, this one only to simulate it, to be more clear and simulate, I use the thread.sleep in the videos. Do you notice it? I've written the code like this. Actually, now 100% wrong results will come. Now 100%. If I don't use thread.sleep, 50% answer, right? Results can come wrong. But now 100% wrong result. Why? Thread 1 starts, go to sleep, thread 2 will start off. Thread 2 starts, go to sleep, thread 3 will start off. First, 1 will wake up, complete the work. 2 will wake up, complete the work. 3 will wake up, complete the work. See now? Are you clear? You don't get the correct results. You don't see the correct result now. 100% guarantee. Now you will never get the correct results. But if I don't use thread, not say 50-50 answers. Sometimes correct results can come. Sometimes wrong results can come. See, one time correct one is coming, one time wrong result is coming. And to fix this problem, what we should use? Locking. And make it as synchronized. Synchronization should be brought into picture. How to do that? We need to lock. We need to lock. How to lock? You need to lock the code present in the method. We need to lock the code present in the method so that it doesn't allow multiple threads to work on it at a time now. Can you understand me or not? What we need to do? We need to lock. I said you one thing as for this locking, already I said you this example. There's a telephone booth, you go inside and lock the door now. Wait, all the people has to wait until you come out. It's also same. You can lock it. How to lock? Remember in the videos also I said you this one. Lock this. This is what I taught in the video. Lock this. But this is giving error, yes. Why? You cannot use this base keyword under static. See guys, in the videos I showed all non-static only. Correct or not? That is why in the classroom I'm telling you static so that you get a clarity. It is static how to write the logic, it is non-static how to write the logic. I showed all non-static in the videos. That's why here I'm showing you all static so that you compare now. Okay, it is static, this is the coding style, and it is non-static, this is the coding style. Okay now? Well, now this is giving error. Why this keyword cannot be used in the static block? We should not use this, guys. We should use the class name only directly here. Static, we use class name only now. How to write? Class 5. But still giving an error, you cannot write directly. Type of. Remember type of operator? It will return you the IL type of the given type now. So it will return you the actual name. What is the actual name? TPL console dot class 5. You should write it like this. It is static. If this method is not static, see now, this is wrong. You should not write like this. How you should write now, you know? Like this. Okay, if it's static, this is how you should write. Okay, now when I use this code now, guys, there is no chance of getting error at any time now. Error will never come. So 50-50 chances? No 50-50 chance. 100% assured you will get correct results only. Check it out. Earlier 3-4 times I execute, sometimes correct results, sometimes wrong results came. But now did you get it? Okay, start preview. Red dot sleep. See, now you won't get wrong results. That one entered. Lock the door. Executing the code, printed console.write C# keys. Went to sleep. Woke up after 5 seconds. Completed the job. Came out. You went to telephone booth. You are sleeping inside now. Or until you come out, everyone has to wait outside now. That is the same thing what is happening here. So you did not see the wrong result now. Are you clear or not? Okay. Are you clear, all of you? The same code I explained you with threading in your video, and here I explained you with tasks. In the notes, I given both guys. First, I given the code with threads. Afterwards, I given the code with task also. Same code only. Same code, nothing difference. See, this code did not change. See, it's the same thing I'm writing for you in the second also. But what I used threads and I used tasks. That's it. The error. What is that? Thread synchronization. Read it. Only one thread to access the resource for the time. No other threads can interrupt until the assigned thread finishes its task. In multi-threading programming, threads are allowed to access any resource for the code execution time. Threads share resources and execute asynchronously. Accessing shared resources critical task that sometimes may halt the system. That's it. See, always it is not a problem. See, each thread calling a different method is never a problem. When the problem comes, multiple threads. See, there also, each thread is accessing a different customer record, not a problem. When the problem came, when they access the same. So we will not lock everything here. We will lock only the methods which are going to have this problem. Every method doesn't require to be locked here. Is that clearer or not? Okay, next. We have C#. Execute program synchronously. Earlier it is asynchronous. Now it is synchronous. It is used to get lock for the current thread, executing the task and release the lock. It ensures that other thread does not interrupt the execution until the execution finishes. Until execution finishes, no one can interrupt it. That is the main agenda of it. Is it clear, guys? Yes or not? Okay, that's what. It is asynchronous programming. When we separate threads, that is asynchronous only. Na? When you are using separate threads, that is asynchronous only. Did you catch my point? When you are using separate threads, that is asynchronous programming. Task is also thread only. Next. Data parallelism. Data parallelism. What is this, sir? Actually, I want to write a for loop here. I want to write a for loop. Imagine when you're writing a for loop, when you guys are writing a for loop, just think like this. The for loop has to execute for 1 million times. By default, the for loop is processed by one thread. By default, the for loop is processed by one thread. There's a for loop. The loop runs for 1 lakh times and inserts 1 lakh records into the table. Are you getting me or not? The loop works 1 lakh times and inserts 1 lakh records into a table. Where is it getting? Actually, right now in my company here, I am developing a project. I'm developing a project here. It's the same project what we have. There are two databases for them. There are two databases. In one database, they have data in different tables. Okay. So what my application has to do is, my application based on, we designed a UI for the application. It has some controls on it. Users will select some values. Based on this, it has to connect to the source database and pull the data and insert the data into another database. Tables are different, not same tables. Are you getting me or not? Tables are different, columns are different. Their data is present in different tables now. So what we should do, we should join them, combine them, and pull the data, and we need to insert them into another database now. That is the current project I'm working right now. Okay, in this process, there are nearly some 10 to 15 tables in the source database, and in the target, I need to insert them into 8 tables. In the first database, there are 15, 16 tables there, but in the second database, I have only 8 tables. I need to take this data, match it, different joins, conditions, or a lot of conditions, everything are written, and we put it in the client's database. Are you getting my point or not? So in this process, for every time I run this, minimum 10 to 15,000 records will come from the first database to second database. How many? 10 to 15,000 records. Internally loops. Internally loops run will. Internally to run a loop now, and the loop will pick one by one record and inserts into the database tables. That inserts into the database tables. That's how we designed it. Okay. So it takes time, guys. Once I start this particular thing, I can go have my lunch and come back. That much time it will take. Are you getting me or not? That much time it will take. If I start this program once, if I start this particular program once, it has to fetch them some multiple records from one database internally. Lot of loops, conditions will check out, and finally, I will build my data according to my requirements, and finally will send it into the database. In one time, 30 minutes, 40 minutes of time also to take it, based on the size of the data. So to improvise this performance, basically for loop is running inside. For loop one by one record it will insert now. To improvise this particular performance, guys, what I can do, I can use threading here also. How can we use threading? Threads will be used for calling methods now. Thread is just for calling method. In one method, you have written all this logic. How can you use threads here? Is that 2 threads? I can use 2 threads now. But in one method, you're writing all the logic. How can you use threads? Actually, in .NET 4.0, they introduced the concept of data parallelism. And in data parallelism, they added a class called as parallel. What is the class name? Parallel. In the parallel class, there is a method called as for and for each. There is a method called as for and for each. Without writing the regular for loop and for each loop, if you call these methods now, internally, threads will be used for executing the logic. Did you understand me or not? I repeat, guys, without using for and for each, use the parallel classes for and for each method. What the for or for each method will do, the for or for each method of the parallel class will internally create you multiple threads to run the code. Understood or not? Suppose, imagine there are 10,000 records to be inserted into the table. Okay, now Generally, by default, only one thread comes now and one thread will be doing the work. But if I use parallel for a parallel for each, imagine, just in assuming that's all, imagine it created 10 threads now. For every thread, 10,000 records are given now. And coming to thread 1, you insert this 10,000. Second, thread 2, you insert this 1,000. Now, parallel will be running now, and it will improvise the performance of the applications here. Did you understand my point? What will happen? All these 10 will be running parallelly and doing the work for you parallelly now. Understood? It will improvise the performance of what? I'll show you an example where this parallel for and sequential for, and will tell you the time difference between the both. I'll show you the time difference between the both. How much time will a for loop take to run the code and how much time a for each loop will take to run the code. We'll try to check the time difference between both the two for a for loop and for each loop. Okay, we'll see about it. Screen not visible. Guys, are you able to see my screen, online students? Someone telling screen not visible. Maruti, I don't know, I have a problem with yourself, I think. Disconnect and connect if you are facing the problem. Watch it. All of you concentrate on this. I wanted to write the same program again. str1 is equals to empty string for int I is equals to 1, I less than or equal to 1 lakh, I plus plus. Same code. I am concatenating 1 to 1 lakh. Sorry. Yeah, I'm concatenating from 1 to 1 lakh. And this is a normal for loop. This is a normal for loop. Now, I'm going to write the same code now by using a parallel for loop now. By using a parallel for loop. How, sir? Watch. String str2 is equals to empty string. How do you write, parallel dot for. Parallel is a class here, for is a method inside of it. It takes a few parameters. 1. Where to start from? 1. 2. Where to end it? 1 lakh. Are you clear? Next. Write your body as a anonymous method. Remember or not, parameter, lambda, expression, and logic, anonymous method. Write your logic as anonymous method. str2 plus equals to I. So both are going to do the same thing only. See, parallel dot first parameter, start from. Second parameter, end it. Third parameter and a body, anonymous method. A parameter and a anonymous method. You are required to write the body. So this is also doing the same thing only. This is also doing the same thing only. What is that? Concatenating from 1 to 1 lakh. Now, I wanted to do one thing. What is it? I wanted to find out the time taken to run. I wanted to find out the time taken to run a sequential for loop and the time taken to run a parallel for loop. How much time the sequential for loop is taken and how much time parallel for loop is taken. And to do that, I explained about a class called stopwatch. Stopwatch. In the videos, I shown you this also in the videos. But not for this, I showed you for a different scenario. Stopwatch, create the instance of it. What do you say? Oh God, wrong place of writing. SW1 dot start, and finally SW1 dot stop. So I'm using a stopwatch, guys. I'm starting before execution and I'm stopping after execution. Do the same thing again. Stopwatch SW2 is equals to new stopwatch 2 dot start. Dot stop. Is that clear? Well, now here I'm writing. Time taken to process the logic by sequential for loop. SW1 dot. That will print you the time taken now. Elapsed milliseconds. To print you the time taken in milliseconds now. Next. Parallel for loop. How much time taken by the parallel for loop now? But the takes time is what I saw earlier. Remember, to concatenate between 1 to 1 lakh, time is taken there. How much time it is taking, we'll calculate now. The time taken to execute the code is 12 seconds for a sequential for loop. The time taken to execute for a parallel loop is 1.6 seconds. 1.6 seconds here, 12 seconds, but here 1.6 seconds now. Is that clear, all of you? Yes or not? That is the difference between sequential loops and parallel loops. Sequential and parallel loops. I said, generally, in this scenario, just shown you, but I said you a live implementation for you. What is it? I have 10,000 records that has to be inserted into my database table now. I pulled all this data from the database. I pulled all the data from the database now, and I modified everything according to my requirements also. Did you catch my point or not? I pulled everything from the database and I modified everything according to my requirements also. I made some changes. After cutting the data, the client said, if suppose there is a column in the source database here, something like a status. Status contains integer values, 1 and 0, or a Boolean value, 1 and 0. But a client, in the client's second database, status of a string column. If 1 is there, active should be stored. If 0 is there, inactive should be stored. So in my query, I written all the logic now. After getting, I manipulated everything based on the conditions. Finally, I have 10,000 records. These 10,000 records should be dumped into the second database. When I'm pushing it in the second database, I use a for loop now. 1 by 1 record. And say the sequential for loop problem, you noticed it now? 1 by 1 record, 1 by 1 record will execute. So go for using parallel. If you go for using parallel, internally, multiple threads will be created. So how many threads will be created? That is not in your or my control. That is not in your or my control. Operating system creates the threads for you. Suppose imagine like for executing this loop of 10,000, imagine operating system has created you 10 threads also. So now what will happen? The whole 10,000 records are divided into batches now. 1 to 1,000, one batch. Okay. Sorry, 1,000, 1 to 2,000 another batch. Now each batch is given for one thread now. Now see, every thread has to process only 1,000 records. Earlier, 10,000 records. Now, 1,000 records. You found a drastic difference in the time now? Yes or not? You found a drastic difference in the time taken. Nearly, there is a difference of 7.5 means, yeah, 7.5 times more. Are you getting it or not? Okay, so that is again 12 seconds, and this has taken only 1.6 second to process the code. Okay, 7.5 times more time it has taken by a sequential loop compared with a parallel loop. This is the other advantage with parallel task parallel libraries. Don't see anything using parallel for anywhere. You did not implement, yeah, you did not implement, but you can implement. You did not see means they did not write it. That is their problem. See, option is there here. You utilize that, don't utilize that is your choice. Okay. So basically, you are writing in a file, they did not use the parallel loop telling. Generally, when you are writing on the files, we don't use parallels. We don't use parallels. Reason is when one is accessing a resource, another one cannot access the same resource. But when you are working with the databases, they'll use parallels. When you go for a database, then what is the best option? Parallels are best option to use. Generally on files, they don't use, may not use. Reason is when one is accessing a resource, another one cannot access the file. But one is accessing a database, any number of people can access the database. So it works good with databases. Okay. But files also, it's not a good option, but there also probabilities are there. But if people doesn't use, that is more mistake. Okay, but Microsoft has given that option for using parallel for loop, parallel for each loop. Parallel for is there, parallel for each is also there. Did you understand about the parallel loop? Basically, it's a class actually. In the class, we have it. Read it. Data parallelism. That's important. What I highlighted is important there. It is partitioned into different blocks now, and each thread will work on one block now. As you suppose I have 10 partitions now. Every partition is associated with one thread now. Okay, next. Parallel class. There's a class called parallel, which is present under the class provides method-based parallel implementation for and for each loop. It has for loop also, for each loop also. Logic won't change here. The body of a normal method and a parallel body same only. Understood? What is that? You do not have to create a thread or a queue. The TPL handles all the low level. You don't require to create the threads now. TPL will do the job for you, creating multiple threads. Internally, I did not create multiple threads here. Who created for me? TPL created the threads for you. And in the next example, I'll show you all those threads also. I'll practically show you a normal for loop, one thread executing the code. In sequential for loop, multiple threads executing the code. I will prove you there are multiple threads running in the code. I'll show you that. But see now, how do you write a sequential? How do you write a parallel is this? Sequential, parallel. Okay. So now I add a class called this one. This has sequential parallel. I'm running for 2 lakh times iterations. Okay. Both of them, I'm just trying to print you the time taken and you notice it. Clearer or not? So much of difference, we notice it. Okay, fine. Next example, tomorrow I'll show you this one. What multiple threads running for you inside. How do I know, sir? Array, print the thread ID. Print the thread ID. Now it will print you multiple thread IDs. For first one, thread ID will be one only. But second one, you'll have multiple thread IDs for it. If you find 5 threads are created. If you find 10 threads are created. That is not in your control and my control. That is completely operating systems control what we have. Is that clearer, all of you? So like this, we can just work with multiple threads behind the screen actually. So hope you guys are clearer. Yes or not? Okay, this is about data parallelism. Data parallelism. Okay, so I show you parallel for tomorrow. I'll show you parallel for each. And mostly tomorrow will be the last session, guys. Tomorrow will be our last session. We'll finish up tomorrow. Okay, let's start here. We'll be tomorrow.